Okay, so today we are still doing stuff with circles. There's one thing that I chose not to put on the test last week that is something that definitely could be done on FSA. So I wanted to wait until this week to go over it. It does require a little bit more algebra than anything else that we've done this year. And it has to do with completing the square. So probably, honestly, you probably don't remember how to do this part of it. If you do, but if not, I'm going to recap a little bit of algebra and then after that, go into the geometry part of it so that you know how to use it. Yeah, how to do it tomorrow. Is that right? Okay. Because I prefer not doing that this week. And I'd rather not do this part. This part's not on that test, but it's something that I think is important to know. Also, the good thing about completing the square, which I think it's important for everybody to know, is it's one of the methods you can use to solve quadratic equations. And although a lot of teachers for some reason stay away from it, I feel like it's one of the easiest methods because it's the same thing every single time, right? It's like you're solving by factoring. There's several different steps to it that can change depending on what type of values you have. Completing the square never changes. Some people like the quadratic formula. Quadratic formula is great, but you have to memorize that whole formula, right? Completing the square is actually how you get the quadratic formula. So if you're here to actually derive it, it's how you do it. So anyway, quadratic equations. So this is a quadratic equation in standard form. Now, standard form of a quadratic equation is something that we use to solve quadratics all the time. It's z equals 0. Down here, I wrote out a perfect square quadratic, also known as a perfect square trinomial. So you have, if you have a binomial that's been squared, it gives you a perfect square trinomial. And this is a perfect square quadratic. Right? So there's a pattern. And the pattern here, if you look at the two terms that we have, the first value is that first term squared. The last value is the second term squared. And then this one in the middle is the two values multiplied together times 2. Now, I know on the paper I gave you, you don't see any of this. I wanted to go over some of these algebraic ideas first. What's on your paper? That is only the geometry part of it. So again, I'd like you to listen through the first like 2-3 slides, and then we'll actually do stuff on that paper in just a minute. So the next thing, solving a perfect square trinomial by factor. So when you factor a perfect square, there's a pattern because of what I just said on the previous page. The perfect square trinomial happens because we took the first term, we squared it. The second term, we squared it. The middle term is 2 values multiplied together times 2. So on here, there's a pattern when we take this apart. This first value here, if I wanted to factor this, I can take the square root of this first term, and it's going to give me x. I can take the square root of this second term, and that's going to give me 4. So I took this first term, took this last term. The sign that's in the middle will give me the sign that goes in the middle of my binomial as a factor that is squared. This same pattern is important because this is how you are going to solve things. And this is what we're going to use in the geometry part of this as well. This pattern of taking that first term, square root it, last term, square root it, and the sign from the middle. Now, you can only do this if it's a perfect square trinomial. So you have to be able to recognize that something is a perfect square in order to use this. But that can be kind of challenging to recognize if something is a perfect square. That takes an extra step because it's recognizing that pattern I had on the previous slide of knowing you have the first term is a perfect square, the last term is a perfect square, and this middle term would be the square root of both of these multiplied together and times 2. That's hard to recognize, and that's confusing. But what's not confusing is once you are doing completing the square, you are making it a perfect square triangle. So you're not trying to guess to see whether or not it is. You already know it's a perfect square because you're making it a perfect square. So once you've made it a perfect square, then you can follow this pattern to solve. So now, let's take a look at an example that would be from algebra. So from algebra here, we are going to look at a problem where we are actually solving by completing the square. We have a quadratic equation. In order to do this, we have to get all the x values on one side of the equation, and we're going to put the constants on the other side. All right. So go through this. So first off, all these x values, we're going to move over here to the left side. So I'm going to have this 12x. I'm going to bring it over. The 10, I'm going to push it over to the other side by subtracting it. So when we do that, we now have 2x squared minus 20x. Oops, I forgot my x tag on that one. Plus, now, there's no third value here, but I'm going to leave a space right now. And I'll explain that in a minute. Over here, this one went away, so that's gone. The negative 36 and negative 10 gives me negative 40. Oh, yeah, 46, thank you. So now, we have values here that I don't recognize this as a perfect square yet. And in fact, is this first term even a perfect square? No, because 2 is not a perfect square. If I have a number with my x squared value, I need to get rid of it. So here, how do I get rid of the 2 that's in front of this thing? Well, I'm going to divide it off. So right now it's being multiplied with x squared. I'm going to go ahead and divide it off of every single value. So that 2 will go away. When I do that, I'm left with just x squared minus 10x plus, I still have this blank here. On this side, I have now negative 20. Now, the reason why I put this blank here is because I need to make this a perfect square triangle. That's what I mean by completing a square. Currently, the first term is a perfect square. I need this last term to be a perfect square as well. Well, there's a way to figure out what number is going to go there. And it's because of this middle term. This middle term is a combination of the first and last term is double. So what I need to do is take that front term. Sometimes we refer to that as the b value. Sometimes we call it the linear number. But here we have this negative 10. We can take that and divide it in half. What's half of 10? 5. And I'm going to take that 5 and I'm going to square it. So my pattern here, I always take that b value, I divide it in half and square it. This is how I know what I'm adding in. Actually, let me color code this so that. So what I'm plugging in here, I'm taking this value, I'm dividing it in half. So 10 divided by 2 and squaring. Now, if I do something to that side of the equation, that's changing my value. I have to balance the equation. So that same thing I did there, I'm going to add to the other side. That 10 over 2 squared. Again, am I always going to write it out like that? No. This value, again, you already told me, 10 divided by 2 is what? 10 divided by 2 is what? 5. 5 squared is 25. So most of the time, I'll just write it in there, 25 like that. Over here. Oops. And you remember how I made a mistake earlier? I just realized I did make a mistake here. The 46, that still looked like 40 to me. I divided it. I should have had a 3 there. I just want to make sure it doesn't come back to haunt me later. So again, this was also 25, right? Now, at this point, this entire side to the left is a perfect square trinomial. Why is that important? Because now I can factor this part into a binomial that's squared. So I take the first term, I'm going to take the square root of it. So I am square rooting. Square root this term, square root this term, and use a sign from the middle when I come up with my binomial. Square root of the first term is x, square root of the last term is 5, sign from the middle is negative. That's where I'm getting those values from. Square root of the first term, square root of the last term, sign from the middle. On the other side, negative 23 and positive 25. Combine those, we get 2. At this point, we have done what's called completing square. We made it a perfect square, and we've also factored it out. So now that we have this binomial that's being squared, that's going to be the part that's important to us in geometry for our circle equations. If this was algebra, if we wanted to keep going with solving this, now all I'd have left to do is take the square root of both sides and then get rid of the 5 by adding. Now let's solve this quadratic equation. So by getting it to this point, the steps are simplified. Now, for geometry, we are doing this for one main reason. Say this. We're looking at equations of circles still. All right. In our equation of a circle, we have all these squares, right? We're actually dealing with quadratic quite a bit here. But in each one of these, the x values by themselves is like one quadratic, the y values by themselves is another quadratic. This equation is what we call standard form. That's what we used all last week. When dealing with a circle, we could also have it written in something called generic form, or sometimes called general form. If it's written in general form, it's not written in a way where you can use it. So in this format, we can identify the center point, we can identify the radius. In the general form, we can't. So the way that we get this from general form back into our standard form is by completing the square. Now, there's steps over here. These steps are the same every single time. So what are we going to do? Well, for the first part of this, I'm going to take the x values. So there's 2 x values here. And we're going to bring those together. So we have x squared. And we have the 16x. We're going to group them together. All right, so I have my square value, I have my linear value. And then, in order to make this a perfect square, I'm missing a third value. I'm going to need a third value here in just a minute. So I left a space. Right here, we're grouping the x's, and we left a space. Then, we're going to do the same thing with the y's. So we have y values. We have plus y squared. The other y was negative 22y. And again, in order to make this a perfect square trinomial, we're going to have a space. The 20 that's on there, we're going to move that over to the other side. So 20, in order to move that over, we're adding it to the other side, so that becomes a positive 20 on the other side of this equation. Well, since I have these 2 blanks over here, in order to balance this equation, I have to have those 2 blanks on the other side of my equation as well. So I'm going to add a space for that first blank and add a space for that second blank. So again, I moved the constant to the other side, and I left 2 spaces. Leave 2 spaces. Now, each one of these I'm treating separate, like its own problem. I have my 3 terms for my trinomial. I need to be a perfect square. In order to make it a perfect square, I'm taking that middle number and I'm dividing it in half and squaring. So what's half of 16? Half of 16 is 8. 8 squared is 64. That's how we figure out what went into that blank. Now, since I put that on this side of the equation, I can't just add a random number here. It's going to change that whole side of the equation. So over here, again, balancing it, I put the 64 in as well. For the other one, the b value here, or the linear value, whatever you want to call it, we have negative 22. What's half of that? 11. And 11 squared? 121. Now, we actually have 2 perfect square trinomials. This is a perfect square trinomial. And this is a perfect square trinomial. So since they are perfect square trinomials, we can now break them down into a binomial that's squared. So we're going to factor this piece. So here comes the part from algebra. All right, we have the first term, the factoring it. We're just taking the square root of the first term. Square root of x squared is x. Square root of 64 is 8. And the sign from the middle is positive. Again, the main things that we're using there. Yeah, we took the square root of this first term, we took the square root of this last term, and we took the sign from the middle. That's where we got these 3 values. So, same thing now for the other one. All right. Plus, what's the square root of the first term there? We had y squared. Square root of y squared is y. I have 121. What's the square root of 121? 11. What's the sign in the middle? Again, how did we get these values? We took the square root of the first term, the square root of the last term, and the sign in the middle. That's what we got, those 3 values. On the other side of the equation, we're just adding these things together now. 20, 64, and 121. It gives us 205. All right. But now this equation is in this format. It becomes useful to us now in geometry because we can identify where the center of that circle is. Using these guys here. So if I wanted to find the center of this one, I could say it's at -8, positive 11. And then this is our radius squared. So I can square root that to get my radius. And we have values that we can actually correct. Again, main focus here, taking an equation, changing it into standard form by completing the square. All right, let's do it again. So we have our equation. Again, rewriting it. We have our x values, x squared. We have our 12x. And then we're going to have some unknown value. For the y's, we have y squared. You have 8y. And then again, you're going to have some unknown value. For the constants, we'll move the 32 over to the other side. And we're still gonna have 2 blanks there, 2 spaces. And pattern continues. So on here, to complete the square, what value are we using to complete square here? How do we figure out that blank again? 12 by 2 and squared. So what's half of 12? 6. 6 squared is 36. So that goes in the blank. Now notice, most of the time, I don't even talk about what sign's in front of it. So yeah, there's negative 12 there. It doesn't really matter at this point. Our number at the end, we square, so it's always going to become positive. Whether you multiply 2 positives or 2 negatives, you get a positive number. All right, for the other one. All right, for the y's. Again, same thing. Look at that middle number. What number should we end up plugging in for our blank this time? Make it a perfect square. Again, we're looking at the 8. What do we have to do with the 8? Divide it in half. All right, divide by 2. So we get 4. And then we square it. So it's 16. And now we have 2 perfect square trinomials. Now we have our trinomials. We can factor it. So what numbers am I going to be able to pull out of here to get a binomial now? So I take the first term and we take the square root. What's the square root of x squared? Okay, well, that's the next term. Yeah, so the square root of x is just, sorry, the square root of x squared is just x. The square root of 36 is 6. The sign is going to be what? The one in the middle, that's going to be the negative. Again, square root of the first term, square root of the last term, sign from the middle. All right, same thing for the next one. What 2 values are going in here? Y. 4. Square root of the first term is just y, square root of the last term is 4. Sign from the middle. Let's sign positive. At the end, combine all your values there. We have negative 32, 36, and 16. That would be a total of what, positive 20 once adding them all up. Again, at this point in time, now we have the equation of a circle, and it's actually useful to us. So if I wanted to actually say, for example, what my center point was, we could say, all right, my center is at a positive 6, negative 4. My radius on this circle, I mean, that's r squared. So you could say it's the square root of 20. Square root of 20. If you wanted to simplify this, you could. Direct 5, or again, you could also do it as a decimal, which is 4 point something, 4.4. I need a calculator, but again, that's how we use it. All right. So on the other side is the actual assignment. Now I'm going to do 4 of these problems. So you're not going to have all of them to do on your own. I'm going to do all the. I'm going to do the first 4 odds on there. So 1, 3, 5, and 7. I'm going to be with you because what we just did, that's the same thing pretty much every single time. However, sometimes we don't have to do as much work. because maybe we aren't given a second x value or a second y value. So some of them can be written a little bit different. Let's take a look at the next one. So on here, the first one, well, that's not really written the same way that the others were. I still want my x and y values to the same side, and I want my constant by itself. So I need to move this y value over to the other side. So I have x squared plus y squared equals 9. Well, do I actually have to do anything on this problem? Do I have to do anything on this problem?
No.
No, we've seen an equation like that before. This one's actually already in standard form. I don't have a linear x value or a linear y value. If I don't have any values next to these, that just means my center point's where?
Oh, it's in 0.
At 0. Yeah, so the center on this one is going to be at 0, 0. And my radius, square root of that, which is 3. Not the best circle ever, but that'll work. All right, on the next one. Now, this one, I only have one x value. So I'm going to put that one first. The y values, there are multiple y values in this one. Now they're already in order, but I do have an extra constant. So I'm going to add, let's see, y squared plus 4y. I'm going to need a space. I'm bringing the 4 to the other side, so now I got 5. All right. On this one, the x doesn't have a linear number with it, so this one we don't have to do anything with. This one, I have a y squared, and I have a linear value for y, so I do need to complete my square here. What is half 4? 2. And 2 squared is 4. So here I'm adding 4 to both sides. Now, I know that we are coming back to the same original equation, but for rewrite this. So we ended up having the same thing that we did at the beginning. I told you earlier, when we do these problems, there is a pattern. If you can recognize the pattern to know that's perfect square already, great. But chances are you wouldn't have known that it was already a perfect square. And that's extra information to remember. So every once in a while, you might move something over and then end up with the same thing. Is it normally going to happen that way? No. But this one, they did give us a perfect square to start off with. So yes, we did end up with the same terms. This is a perfect square trinomial. We can factor it. Square of the first term is y. Square of the last term is 2. Sign from the middle is positive. And we have our equation of the circle in standard form. Where's the center? The x value is at 0. The y value is at -2. And the radius is 0, -2. Radius is 3, so we got 3 in each direction. Now, the next example is just like the ones that were on the back. We have both an x squared and a linear x value. We have a y squared and a linear y value, and we have a constant. We're doing the whole thing this time. So, put them in order. X squared plus 4x plus blank. Then we have our y's plus y squared plus 4y, not plus 4y, it's minus 4y plus blank equals, the one goes to the other side, becomes positive. Again, I need two blanks, one for each of the blanks I put in over here. What goes in the blank? Well, again, looking at the middle term, 4 divided in half, you get 2. 2 squared is 4. That's our perfect square triangle. For the y's, again, we have 4 in the middle, so half of 4 is 2, 2 squared is 4. That is now also a perfect square trinomial. Only real big difference here is the variable and the sign of that middle term. So on this one, square of the first term is x, square of the second term is 2, sign from the middle is positive. On this one, sign of square of the first term is y, square of the last term is 2, sign from the middle is negative. Oh, I did forget to do something up here. What did I forget to do? I got to plug in my values, so that I plugged in on this side. Again, don't forget to balance it. Both of those are 4s. 1, 4, and 4 is 9. So our center here is -2, +2, and the radius of -2, +2. I do want to do one more with you, number 7. Brings in one more aspect of this. I need to take a picture before I get rid of it. Last off. All right, moving on to the last problem. All right, we're doing 7 together. So on 7, we only have one x value. We have 2 y values. So again, it's in a nice order there. We still need a blank added in, and we need to get the constant over to the other side. So we got 4x squared plus 4y squared plus 32y plus blank equals 36 plus blank. Now, I only put one blank on the other side because we only add one blank to the left side of our equation. But there's one other thing that we need to do before we can do anything else. On here, for both of our x value, our x squared and our y squared values, we have a lead coefficient. We've only seen one other problem like this. In the algebra part, the little review part I gave you one where we had a 2 out in front. And remember what we had to do with that to get rid of it? So on here, we have a number out in front. We can't have a number out in front. We gotta divide every single number by 4. Exactly. So on here, before we can go to the next part, we need to divide off 4 from each of these, so that we no longer have that lead coefficient. So x squared plus y squared plus 8y blank equals 9 plus blank. All right. Now we can go ahead and figure out this last term. Because if we had done this part before getting rid of that, it's still within a perfect square trinomial, because you have to make sure that there's a certain pattern that it follows. So on here, 8 divided by 2 is 4. 4 squared is 16. So plug in 16. We now have a perfect square trinomial. And we get back to that part. Square root of the first term, square root of the last term, sine from the middle. On the other side, 9 and 16 is 25. I forgot the plus sign. So center is at what coordinates? For x value, it's at 0. The y value, -4. The radius, again, 25 is the radius squared, so square root of that is 5. 4. Radius of 5. That's the horrible circle, but it'll do. All right. Again, there are still 6 more problems on there for you guys to try. They vary by how hard they are. Yeah, I'd like you to try them. Like I said, this is not something that I know I didn't test on this last week, but it is something that you'll most likely see at least the problem 2 on the FSA. So it's a good thing to make sure I went over. Also, when you go to Algebra 2 next year, you'll be solving quadratics again. And like I said, Leland square, I think is in the long run one of the easier ways to solve a quadratic because it's consistent, you do the same steps every time. Now, when you solve a quadratic in Algebra 2, you're not doing an x and y at the same time. There's a lot of work here when you're doing it with the circles because you have 2 separate equations that you're doing all at the same time. But again, it's consistent, it's a pattern.